In Lesson 14, you will have begun to introduce your students to the group of polyatomic ions. Now, these ions have more than one element present in them, and they can be kind of tough for some students to get a handle on. We've gone ahead and made this segment of the video to go through the master list of these ions and help you see some trends and some ways that you can help your students learn them and then have greater success in the rest of the course. So what we're going to do is take this master list. Now it's found in the student book on page 129 in the student book, and then in the teacher edition on page 227 if you're using the group teacher edition there. It's the master list of ions, and you can see that these are the ones that we're going to use throughout the remainder of the course. These are the most commonly found ones in basic chemistry, freshman college chemistry course, and so that's the ones we're going to concentrate here on. Now in our list you can see we've divided them into two columns, two sets. We've got the anions on this side and then the cations over here. What we're going to do first is concentrate on these anions. They're usually the ones that are a little more tough for students to master, and then we'll look at some of the cations. Now this is the master list, meaning it does also include many of the monoatomic ions that you've already introduced to your students. Those are the ones that are easy to determine the charge on based upon where they are on the periodic table. And so we can quickly look at those. We've got bromide, for example, chloride on here. Then we've got the halogens, some fluoride, iodide, oxide, sulfide. And then over on the cation side, there's several of those that you've already introduced to your students, which are rather easy to memorize and know the charge of just based upon where they're at on the periodic table. So let's, before we jump right into some of these, let me give you some little rules here that'll make things easier. Okay, in these polyatomic anions, we'll find some that have the ending of their name as ite or ate, ite and ate. The example might be something like here. Let's go down clear to, we've got nitrite and nitrate, and then we have sulfite and sulfate right there. Any ion that has the ending ite or ate in it will also have, as one of its elements, oxygen present. So when you see ion ends in ite, as in nitrite or nitrate, oxygen is going to be present. Let's look at this nitrite and nitrate. The beginning of the name tells you the other element that's present. So we have nite, so that indicates it's going to be nitrogen, and the ite tells us we've got oxygen present. Remember to always use your parentheses to make sure that your students are aware that these two elements act together. These two atoms, or combination of atoms, work together as one unit. So we'll always use the parentheses. Okay, and then we've got nitrite and nitrate, and I'm going to go ahead and put down another set right here for you. Okay, nitrite ends in oxygen, nitrate ends in has oxygen in it also. The next thing is that the ions that come in sets like these, like nitrite and nitrate, the ion that ends in ite, the ite, will have fewer oxygens than the ion that ends in ate, ate. So we say ite has fewer than 8, or ite is less than 8. So in the case of nitrite here, nitrite has 2 oxygens present, whereas nitrate has 3 oxygens present. Now knowing these numbers down here, there's not much logic to it. You just going to have to tell your students they have to memorize which combination of the multiples of oxygen that these ions have. We'll look at sulfite and sulfate here in a moment, and we'll see it's not a 2 and a 3, it's a 3 and a 4. However, the rule stands that the ite partner of the group, the ite component of the pair there, ite is always going to have fewer than the 8 does. Alrighty, so we've looked at nitrite and nitrate. Now, these both have a -1 charge. And this charge out here, being able to calculate readily what the charge is again rather illogical. There are theories behind it which explain that, but for the extent and complexity of our friendly chemistry course, it's best just to have your students understand to memorize these charges out here. So, ite's less than 8. In the case of nitrite and nitrate, nitrite will have fewer than the nitrate. The charge is written on the outside to help indicate that the charge functions on the whole, has its effect on the whole ion there. Alright, let's look at a couple more here now. While we're talking about ite and 8, let's go down here to sulfite and sulfate while we've got this ite and 8 concept going here. So we have sulfite. Sulf tells you it's got oxygen. If we said ite, we've got ITE again. Alrighty, so we know we've got oxygen present. And then we have sulfate. Sulf says sulfur. Sulfate now says we've got oxygen. Ite or 8 means oxygen. Alright, in the case of sulfite and sulfate, it's going to be a 3 and a 4, like I mentioned just a moment ago. Sulfite is SO3, sulfate SO4, and in this case they both have -2s. And figuring out this charge from anything in here, again, doesn't make a good bit of sense. So again, memorization of these charge here. I'll go through a little memory jingles and aids that we've made up as we go through some of these, and it'll help your students memorize some of these numbers here. Okay, so we've got sulfite and sulfate so far. I want to take you now back onto the list, and we're going to work our way down and look at some of the trends and similarities between the two. Okay, the very first one on the list here is acetate, and we're going to skip that one for now. It's the most complex by far. We're just going to skip that one for now. Bromide is one that's a monoatomic, so we've already discussed that one. Next, carbonate. Carbonate there. Notice that its ending of its name is ATE, carbonate. So we have carbon, and the 8 means oxygen. So we're going to have carbon and oxygen. And in this case, it's CO3 -2. Now we don't have a carbonite. Carbonite's not a common ion, so we're just going to work with carbonate in this situation. Carbonate. Now, a little jingle I've taught my students in the past goes like this. Now, carbonate is part of when it's got an extra couple hydrogens on it, and don't worry with understanding these extra hydrogens, but when it has some hydrogens to make the compound here, this becomes carbonic acid. And carbonic acid is a compound that's used to make carbonated water. Now, carbonated water is water that has basically carbon dioxide dissolved in it, and that's what makes the fizz in soda pop, in soft drinks. And so carbonate here makes up carbonated water, which makes up soda pop water. So the way I tell my students to help memorize carbonate is Coca-Cola is a soft drink. So we have CO for the co here, okay? And we say a Coke at 3 will keep you up till 2 in the morning, as in the caffeine in the pop. So we say a Coke at 3 will keep you up till 2. So that's just a silly little memory aid there to help you and your students. So again, we have carbonate. 8 means oxygen, and just have to memorize the charge out there. Okay, let's go back here now. We've got a set coming up next, which can be a little overwhelming when you first take a look, but we'll break them down and hopefully it'll make sense. So we've got carbonate done here. Next one is chloride. Notice that chloride ends in IDE. IDE. There's no ite or ate. No oxygen. No oxygen in chloride. It's just plain old chlorine ionizes to chloride. But take a look at the next set of 4 there. Let me get them here. Okay, we've got hypochlorite, chlorite, chlorate, and perchlorate. Let's look at this set of 4 here. Notice that in each of these, they end in ite, ate, and ate. And we've got chlor, 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 which tells us that we've got a combination of chlorine and oxygen. And then we have a varying number of oxygens as we go down through this set. So the first 2 we have are hypochlorite and chlorite. Okay, so we're going to look here. We've got ClO and ClO, and we're going to use our parentheses again. Okay, so we've got hypochlorite and just plain chlorite. Now hypo, the prefix hypo, if you're familiar with the term hypothermia, means low temperatures, or a hypodermic needle is one that goes under the skin. Hypo means low or beneath or under. So hypochlorite is going to be the lowest, the ion with the lowest number of oxygens. So hypochlorite is going to be ClO1. Okay, so we have hypochlorite. Then the next one down was chlorite. Righty? So it's going to be ClO2. Now both of these are ites. So as a set, they're both ites, and they're going to come before the next 2, which are both ates. There's 2 of those that end in ATE. Righty? So we've got hypo is the lowest, hypochlorite, then just plain old chlorite. Then we've got chlorate next. So it's going to be ClO3. These are parentheses again. This is chlorate. And then we have perchlorate. Perchlorate. Now, the per, I tell my students, is short for hyper. Hyperchlorate. Now, in chemistry, they take off the HY and just use the per. But if you think about hyper, have you ever heard of hyperactive or hyperthermia? We had hypothermia up here, which is very cold. The opposite of that is hyper. Hyperthermia is overheating or too much heat. Hyperactive is too active. So we have, in essence, we've got hyperchlorate, which is going to be the one with the most oxygen. It's got 4 oxygens. And again, we'll put our parentheses here on the outside of that. So we have a combination of chlorine and 4 oxygen. Chlorine, 3 oxygen for the chlorate. Chlorite, ClO2. Hypo, low, is ClO1. And we've got ites lower than ates. Ites less than ates. So there's our set of 4 on our sheet here that look kind of intimidating. Where are they? Right here. Hypo down to here. Now if we go back up to that chloride, it's kind of obviously a component ion that's related there. But again, you see it ends in IDE. no I or 8, no oxygen. So it's just plain old chloride. Okay, so that takes us down here. Fluoride, iodide, those are just halogens you're already familiar with. Oxide and sulfide. Then we come to our buddies here again, sulfite and sulfate. We've talked about those. 3s and 4s. Oh, if we go back up here real quick, the charges. Charges on all these chloride ones and chlorites and chlorates, all -1s. All -1s. And if you know, here's a little helper for you too. You can determine the charge on chloride easily just by finding it on the periodic table. It's a halogen and gains that 1 electron. So it's a -1 charge. If you know that charge, it's the same charge on the rest of all these chlorites and chlorates, all -1s. All right, let's go back down to the sulfites and sulfates. Sulfites, less than sulfate, SO3, SO4. And again with the charge. You know the charge on sulfide. It's a -2. It's an oxygen family member, so it gains 2 electrons. Therefore, it's got a -2 charge. And then the sulfite and sulfate, also -2 charges. The next set 2 down are ones we've already looked at earlier, is the nitrite and nitrate. We've got an NO2 -1 and an NO3 -1. The little memory aid I talk about for students for nitrite and nitrate is I think about nite as nitrogen, but I also think reminds me of the time of day or is at nighttime. So what I tell my students is that it's dark between 2 and 3 in the morning, but darkest at 1 in the morning. So it's night, my nitrites and nitrates. It's dark at 2 and 3, that's the number of oxygens, but darkest at 1, and there's my -1 charge. Now remember, these are all anions, so all our charges are going to be negatives over here. So there's my memory aid for the nitrite and the nitrate. Dark between 2 and 3, but darkest at 1. If we go back up to the sulfite and sulfate, a memory aid there is the S makes me, this is just random kind of, makes me think of school. S starts with school, and S for sulfite and sulfate. We get out of school between 3 and 4 in the afternoon, but sometimes at 2. So sulfite and sulfate, the S's starts with school, S for school. We get out of school between 3 and 4 in the afternoon, but sometimes at 2. So there's your little memory aid for those two. All right, so let's move on down. We've got 2 here next, which are just rather bizarre ones. Let's take them apart though, maybe we can make it a little easier. We've got chromate and dichromate. Chromate and dichromate. Notice that they both end in ate, ATE, therefore we know we've got oxygen, and sure enough we can find it right there. Chromate and the dichromate. Alrighty, now the chromate to me looks a lot like sulfate up here. Notice we've got CrO4S, O4, same number of oxygen, same charge. So I tell my students that chromate and sulfate are cousins. They look a lot alike. Righty? So we've got sulfate SO4 -2, chromate CrO4 -2. The CR is for the chromium. 8 tells you it's got oxygen in it, and then you just got to memorize the charge there. Okay. Now, chromate has a brother named dichromate. Alrighty. Now the di out front tells us we've got 2 chromium atoms here. So that's why we have Cr2 in our ion. And then we have 8 tells us we've got oxygen. This time we have 7 oxygen, and then a charge of -2. So this is just one you just have to buckle down and memorize. Maybe you can come up with some sort of memory aid for this one yourself. Dichromate, Cr2, O7, -2. So there's our chromate and dichromate. Moving on down the list, we have cyanide, which is a poison, right? Cyanide, now this one, I've watched students try to find this on the periodic table. There's no element named cyanide that ionizes. Cyanide is a combination, now it's polyatomic, of carbon and nitrogen. Carbon and nitrogen, one of each with a -1 charge is cyanide. And some memory aid for this one is too much CNN, or like too much TV, can be considered poisonous. Cyanide is a poison that's used to control different rodents and stuff. Cyanide is, so it's CN, so we say too much C and N. CN is poisonous, so CN -1. Now, next one we have on the list is Pur Manganate. Pur Manganate. ATE tells you, you bet, it's got oxygen. You can see them right there. The mangan refers to manganese. Okay, now not magnesium here, but manganese, so it's Mn. And the per out front, if we go back up on our list here, remember perchlorate? We said that the per is like short for hyper, which was the one with the most, in this case 4 oxygens. So our permanganate has the most oxygen, so it's got 4 again. So we have permanganate, so Mn is for the manganese, 8's oxygen, so MnO4 -1 charge. And in this one again, memorizing the charge is about the best you can do for that one. So, permanganate. Next we have peroxide. Per again means we've got extra or a lot. In this case though, we don't have 4 of it, we only have 2. Now let's compare peroxide back up to one we're familiar with, oxide. This is just plain old oxygen, the -2 charge from the oxygen family. Peroxide means it has more, so we've got O2, same -2 charge. So oxide is just O1 -2. Peroxide is O2 -2. How about phosphate here? Phosphate, the phos indicates phosphorus, 8 indicates oxygen, PO4 -3. Now this is phosphate is the only -3 anion that we're going to have in the course. Phosphate only -3 one on the whole list there. And the memory aid I have here, phosphate is phosphorus anion here, and this is one of those chemicals used on the ends of matches. And so to bring that back in focus with your students, phosphorus is on the end of a match, and so the memory aid is it takes 4 matches to make a fire, but 3 will work. 4 for the number of oxygens, 3 for the charge. So it takes 4 matches to make a fire, but 3 will sure work. That's phosphate for you. The last one on our list here is hydroxide. Hydroxide, we've got hydra, tells us we've got hydrogen. Oxide, we've got oxygen. OH, it's traditionally written in reverse there. If you say hydroxide, we think maybe the hydrogen needs to be written first. But conventionally it's written OH, one of each, with a -1 charge. Alright, that's hydroxide there. One we skipped at the very top of the list now was our acetate. Acetate. Now, acetate is the only anion we're going to look at that has 3 different elements present. We've got carbons, hydrogens, and oxygens in this ion. Now, acetate is, if we added a hydrogen cation out front, if we made it hydrogen acetate, let me draw it here on the board for you. Hydrogen acetate is, so we've got a hydrogen, H1, and then we've got acetate. So I'm going to put my parentheses, C2H3O2, and it's a -1. And so you'll teach your students that, we'll make compounds out of these, so we'll just have 1 and 1 of each. This hydrogen acetate is acetic acid, and the common name for acetic acid is vinegar. So vinegar that's used to turn cucumbers into pickles, make cleaning agents for your house. Vinegar is acetic acid, and this is the formula for it right here, hydrogen acetate. So what I tell my students, actually my daughter and some other girls in their chemistry class came up with this memory aid. They said we have two curvy pickles, 3 straight pickles, and 2 circle pickles make up a whole jar, 1 jar of pickles. So the acetate is acetic acid to make pickles. So we have 2 curvy pickles, 3 straight pickles, 2 circle pickles, make up 1 whole jar of pickles there. So that's your C2H3O2 is acetate. So that's our list of anions here. We talked about how if it has ite or ate present, it'll have oxygen in it. Righty? The one here that's a little bit different, don't confuse if it says oxide. Obviously that has oxygen in it. And the other one down here, the peroxide and hydroxide, they don't have ite or ate, but they certainly have oxide in them, which is the oxygen. Ready? The ites and ates have oxygen in them. The combinations of the two, like the nitrite and nitrate, the one that ends in ite has fewer oxygens than the one that ends in ate. So we've got NO2, NO3. Our school ones there, the sulfite and sulfate, are the 3 and the 4 combination. And then we talked about the prefixes on some of these, like the hypo and the pur. The hypo means low, and the pur, which is short for hyper, means a lot, so more, the most. So it was the 4 in the case here of perchlorate. So there's your anion side of the chart. We'll look at the cation side here next. Okay, let's take a look at the cation side of our chart now. Cations, remember, are the ions that are positively charged. So everything over here is going to be a plus charge on it. And many of these are ones that we've already looked at earlier, and we can readily, they're the monoatomic ones that we can readily find on the periodic table, and based on their location, know their charge. So let's look at some of those common ones. Okay, aluminum right here. Aluminum can be readily found on the chart. Know it's Al plus 3. Now the next one down, chromium. Chromium is one of those outlaws, those transition elements that it's kind of tricky to know their charge based upon where they are on the periodic table. So it's one we have to memorize. A memory aid for that one I've shared with my students is that aluminum and chromium are third cousins. Now there's the third just indicates they've got that plus 3, and they kind of sound the same. So aluminum and chromium, third cousins, Al plus 3, Cr plus 3. Now hydrogen, sodium, lithium, potassium, those are all sodium family members. That's easy to know, they're plus 1s. Calcium, magnesium, strontium, those are all calcium family members and plus 2s, so those are easy. Then we've got nickel and zinc here that are a little bit hard, because those again are some of those outlaws, those transition elements that it's hard to know their charges, and actually they can have more than one charge depending on the conditions that they're under. So we have to memorize these here. So nickel and zinc. Nickel is Ni plus 2. Zinc, Zn plus 2. Memory aids for these, I tell my students, well, take a look. We know nickel, the symbol for nickel is Ni. The N, if you use your imagination and lay it on its side, look at that. That N kind of looks like a 2 almost. If you use your imagination here, the N looks like a 2. So the nickel is Ni plus 2, and the zinc, the Z looks like a 2, therefore it's a Zn plus 2. So nickel and zinc, Ni plus 2, zinc, Zn plus 2. Silver, another one that's a transition element, therefore we don't have much logic to determine its charge. So silver, Ag plus 1. You need a memory aid for that one. Sometimes students say, well, silver wedding band means there's only one for me. So silver, Ag plus 1. The sides of the A are straight, which makes you think about a 1. So Ag plus 1. You may want to come up with your own memory aid for that one. Then we have hydronium. Now it's just kind of a crazy one here. Hydronium, H3O plus 1. Hydronium kind of looks like water, doesn't it? And hydro makes you think about hydrant or hydrate or hydration, dehydration. Hydro refers to water. Carbohydrates have water and carbon atoms in them. So hydronium is water that has an extra hydrogen. So I say this is glorified water. It's water that's got an extra hydrogen in it. Water, you know, is just H2O, and it's a stable compound. Hydronium is H3O. It's got an extra hydrogen in here. It's glorified. So it's going to take on that extra plus 1 charge there. So this is just water. This is hydronium, glorified water. Okay, so there's your hydronium. Now cesium is a member of the sodium family, so that's an easy one there. Then we have ammonium. Ammonium. Now we need to point out to your students that ammonium is not the same thing as ammonia. Ammonium is NH4. It's an ion now, cation, with a plus 1 charge. Ammonia is NH3, and that's a stable compound. Righty? Let's look at those on the board here. I'm going to point this out because this is important for your students to realize the subtle difference here. Ammonia, which is like a cleaner, the smelly kind of cleaner that can really open up your sinuses if you take a whiff of it, or if you go in a barn that's had a lot of urine in it for a week or so in the winter time, you'll get that ammonia smell. That's NH3 there. That's ammonia. All right. Ammonium is NH4, and it is a cation. All right. This is stable compound. This has got enough pluses and minuses. Everybody's happy here. But ammonium has that extra hydrogen, kind of like the glorified hydronium was a little minute ago. Ammonium, NH4 plus 1. Okay, so this is ammonium is used in fertilizers. Farmers and horticulturists use ammonium to get nitrogen to plants. Nitrogen is the element which plants use to create their chlorophyll so they can do photosynthesis. Ammonium is often used in fertilizers, and so this is one you can say, well, this is a fertilizer, and farmers use it to do what? To get nitrogen in the ground, and farmers work until 4 in the afternoon and sometimes till 1 in the morning. This is just a silly little memory aid here. So the main thing here is to remember that ammonium is a fertilizer used in fertilizers, and it's to get the nitrogen. And then you might come up with a memory aid there for your students. Alrighty, that takes us down to this set of cations here at the bottom, starting with Mercury. And this is an interesting set because these ions here are written with Roman numerals after their name. We've got Mercury 1, Mercury 2, Copper 1, Copper 2, Tin 2, Tin 4, and then we have Lead 2 and Lead 4, Iron 2 and Iron 3. The Roman numeral here tells you the charge. The Roman numeral tells you the charge. So Mercury is Hg plus 1. Mercury 2, Hg plus 2. Copper 1, Cu plus 1. Copper 2, Cu plus 2. Then Tin 2 and Tin 4, we've got Tin 2, Sn plus 2, Sn plus 4. Same with the leads and same with the irons down here. The Roman numeral tells you the charge. Now, this is somewhat of a more newer way of writing these. The old terms, which have become obsolete now, and it's mainly for safety reasons, they used endings which were IC and OUS. For example, the Copper 1 and the Copper 2, right down here, the Copper 1 and Copper 2, the Copper 1 originally was called cupric, C-U-P-R, cupric. The Copper 2 was cuprous, C-U-P-R, where the cuprum is the older name for copper, and that's why it has the Cu symbol there. So cupric and cuprous, and then we had for the tin, it was stannic and stannous, and the lead was plumbic and plumbus, and ferrum and ferric and ferrous, and there was confusion in those. People could not remember and often would grab the wrong compound off the shelf because they could not remember which of these, which was in this case the +1 and the +2, and so to make there less confusion and therefore less dangerous for persons using chemical compounds, they've gone to this Roman numeral system. So if it's Cu plus 1, it's just copper Roman numeral 1 there, and the Cu plus 2 is copper Roman numeral 2. So this set in essence are the easy ones because the Roman numeral tells you the charge. So Mercury 1 is +1, Mercury 2 is a +2, and so forth on down the list. So this is your set of cations now that we're going to use for the rest of the course, and then we have your list of anions on this side with the ites and the ates and the purs and the hypos and so forth. So your students will need to have a good handle on these. It's your call as to whether you allow your students access to this sheet on tests. I strongly recommend that they have access to it, of course, while they're working the practice pages, but then on tests, it's up to you how strict you want to be with having them memorize this list of ions. This list set will definitely be used for the remainder of the course. They'll definitely have to have a good idea of what these are, but if you want to let them have access to it to check on them, that's up to you. It's critical that they know the charges, because any little mistake as they move forward in the course with these can be a really headache as they learn the new concepts. So there is also a set of online flashcards that we've created. If you go to our website, you can find a link to this flashcard set. Basically, it shows a ion, whether it's mono or polyatomic, and then it gives your students an opportunity to identify it, and on the very next slide it shows the name or the symbol depending where you're at in the flashcard set. Also, another game you can play is the Polyatomic Ion Bingo, which we'll look at in the next segment on this tape.